Well then, fancy meeting you here at the Daily Space Weather. We've got the in-depth coverage that you're looking for. If you're looking for the in-depth coverage, the most comprehensive in the world when it comes to Daily Space Weather content, welcome to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. Thanks to all of our spaced-out viewers for tuning in. Here's the past 24 hours in SDO, 193 plus 304 angstroms. And we've got massive filaments. We've got 4 new sunspot groups in the northeast. Here's the equatorial view. Massive number of filaments. We've named like 5 of them at the moment. Any of those could turn into coronal mass ejections. Here's another view of the southern hemisphere, the south polar region, some great filamentary reorientations happening there behind our Earth scale, and that motion that you're seeing, that is the SDO calibration maneuver, ensuring that the aperture is focused on the center of the solar disk. That will not be present in tomorrow's Daily Space Weather video. And by the way, we've got a cosmic ray report coming today. And by the way, press the like button. We're not asking, we're telling. Press the like button, folks. We need your assistance to get the content onto screens as we attempt to make this into a sustainable operation. If your friends and foes aren't familiar with space weather, perhaps send them our shorts. We've got lots and lots and lots of content. The most detailed solar imagery that you'll find in the known universe. And the most comprehensive daily space weather content. So press the like button, press the share button, press comment. Tell your friends and foes about the channel. Thanks to everybody who has. Thanks to the Smash team for supporting the channel. And let's throw all of our advertisements in the beginning of the video as we attempt to make this a sustainable operation as it approaches 7 years of daily space weather content. So, by the way, it's expensive. It's good and fast, but not cheap. So today's featured product is Choose 2. Yeah, Choose 2. You get 2. It's either going to be good and fast, but not cheap. Fast and cheap, but not good. Avoid that one at all costs. Or it could be good and cheap, but not fast. You won't get all 3, and project managers wishing you had all 3 are hacky project managers. So, yeah, that's today's featured merch product. You can find that linked below the video. Project management facts. You don't get 3. It's either good and fast but not cheap, good and cheap but not fast, or fast and cheap but not good. 36 more designs also available there in dozens and dozens of different types of products, whether it's throw blankets, scarves, t-shirts, mini skirts, tights, socks, and more. Check out those products. Next, the best way to support the channel is by becoming a member of the Smash team. Once again, shout out to the Smash team. Thanks for continuing to increase the probability these videos will remain existent, publicly visible, and free for all to view. Smashomash.com/Smash team. It's the official subscription services site. We launched our own because there was insufficient capability in any others. So we built our own. Shout out to Smash staff. Give her a raise by becoming a silver or perhaps a gold Smash team member. You get additional content. That's the whole purpose of it. Silver level gets more. Gold gets even more than that. The gold annual paid-up subscription is the best value of all. It includes complimentary merch. Like that. Another way to support the channel is via our paid affiliates. So here's a paid endorsement. Amazon.com/shop/Smashomash is one place to support the channel. And today we're talking about sleep products. So magnesium, it makes some people drowsy. Perhaps pick up some from our Amazon shop. Again, it's Amazon.com/shop/Smashomash. You can find links to most of the supplements that I take. I take magnesium before bed. Don't take it with calcium, folks. They're co-antagonists. They cancel each other out. Magnesium, it might help you sleep, so perhaps try it out. It's also good for bone and muscle health. Save 20% there on the Amazon store, linked below the video. right conveniently in the description for your clicking pleasure. Another sleep product is the Sleep Stacks, the broad-spectrum CBN capsules from Hemp Lucid. Herbs and mushrooms might help you sleep, so perhaps check those out. Save $15 on sleep, immune, and stress stacks. That's today's featured product, the Sleep Stacks from Hemp Lucid, also linked below this very video. You can also find links on the homepage. SmashOmash.com is the homepage. And by the way, welcome to the Neo-Renaissance. In 2019, a crack YouTube unit was sent to social media prison for a crime we did not commit. We promptly escaped a maximum security social media stockade of the Internet Underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. Did you know we have trouble finding our own content at times? Yeah, if you're not getting notifications from this organization, sign up for email alerts at smashomash.com/Smash team. We even send those out to bronze level members for videos just like this one. So yeah, support the channel via clicks if you're unable or unwilling to open your cobweb-encrusted wallet and send us a few bucks per month to continue creating this content. And let's talk about Sunspot. So we had some evolution of this Sunspot. It's trading some Umbre there. One Umbra moving much faster than the rest. And again, we've got 4 Sunspot groups up here in the Northeast. So they ain't got names yet, but it's expected that they will in the next 24 hours. Here's the colorized magnetogram. And another thing to note is that there is disorganized magnetism going on in the eastern limb. So you can see some blotchiness here. So there's a magnetic tug-of-war going on over there. And we'll show you more imagery of that a little bit later. First, it's the Bagashov volcano. It's not the Bagashov. It's the what is it called? It's the Bogoslav. The Bogoslav volcano, located in the Aleutian Islands, now on the list. Also a great view there of Kluchevskoy, which has created a new cinder cone inside of its main caldera. So these are the volcanoes that are erupting. Kluchevskoy, an uptick there as it explodes. It's producing a 25,000-foot plume of volcanic ash over the Kamchatka Peninsula. So lava fountaining has made a new cinder cone there. Sakurajima also producing an 8,000-foot ash plume. Subanosejima, 6,000-foot ash plume as Subanosejima explodes. Eruption at Mount Mayan, unknown volcanic ash plume over Luzon Island, Philippines. Ibu, 7,000-foot ash plume. Luatolo exploding, 7,000-foot ash plume, flight level 070. Semeru, flight level 140 over East Java, Indonesia. Dakono, 7,000-foot ash plume as it explodes. And there's Bogoslav. So increased seismic activity there, some seismic unrest over the past 90 days at Bogoslav in the Aleutian Islands. Volcanic alert level yellow for Bogoslav. Headed to the mainland of North America, Popocatépetl continues to explode. Flight level 230 over central Mexico. It's a 23,000-foot ash plume. Volcanic ash not observed over Nevado del Ruiz. Sangay in Ecuador, volcanic ash not observed. They could both be erupting. It could be cloudy for the satellites. Revenador exploding, flight level 150, and Sabancaya exploding, flight level 230 over Peru. It's a 23,000-foot volcanic plume of ash, flight level 230. Next, seismic activity, and Iceland had an interesting quake. Iceland experiencing a 5.1. There are the past 90 days. Here are the past 24 hours of 5 and greater magnitude quakes. So yeah, a 5.1 at a historically not so active location there on Iceland. Interestingly enough, if you bring up the interactive map, check it out. Historic seismicity, not so common where that 5.1 occurred. So perhaps a new era of seismic activity there starting up on Iceland. 5.1 occurred at 22:19 Universal Time yesterday evening. Then at 3:49 this morning on October 25th, we had a 5.2 at Papua New Guinea. And then quite some time with no 5 magnitude quakes until the drought breaks with a 5.2 at Indonesia. That was at 13:24 Universal Time this afternoon. And then only about an hour later, a 5.1 at the Solomon Islands. And then a little under an hour after that, a 5.2 down at the South Sandwich Islands. And those are the quakes of the past 24. Taking another look at the closest star here. Here is 171 angstroms, the house favorite wavelength. And by the way, you might see some plasma motions right in here. We did not detect a coronal mass ejection from that. And we'll show you more footage of that a little bit later. That looks like it was a reorganization and perhaps a partial collapse of that Mark Zuckerberg solar filament. Here's a little closer view. Again, you'll see that filament move it around there. You'll see some brightening. Again, it looks like part of it collapsed, but part of it still remains intact. So we don't think there was a coronal mass ejection from that. And let's talk some additional space weather stats. Oh, wait a minute. Here's a close-up first of there is the northeastern limb. That's where all the action has been. Some C-class flares coming from that area. And it looks like perhaps some more sunspots about to rise as well behind that northeastern limb. So that's really the most interesting spot at the moment. And we've also got the southeastern limb. Check it out. So that's what's going on in the southeast. Big plasma filaments down there, which is what we're highlighting there. To the west of the Earth scale primarily, multiple large plasma filaments hanging out in that region. So, now getting to some stats, the 10.7 centimeter radial flux now at 126 solar flux units, a modest uptick in the radial flux, which by the way comes from the upper chromosphere and lower corona, right about where my mouse pointer is. And here's the 1 year graph. Oh, it's telling me 122. I thought it was 126. Yeah, it is 126. So that looks like it needs to be updated there. That is Solon.info's data. The last year depicted there in black. The black line is the 10.7 centimeter radial flux. The red line is a sunspot number, which actually has dipped officially since yesterday, but don't expect that to continue. We'll tell you why momentarily. NOAA not forecasting any geomagnetic storms or geomagnetic unrest. You can follow it yourself if you like at the Space Weather Enthusiast's dashboard. And here are the past 4 hours of Earth's magnetic moment from space. We've got a pretty nominal solar wind density here and a slow solar wind speed. So that's the magnetohydrodynamic pressure to about 12 Earth diameters there, and things are looking quite average here at the moment. So that's the last 4 hours from space. Here are the last 4 hours of Earth's magnetic moment from the ground. If you're spooked of a pole flip, well, I don't see it happening. Where are the quadrupoles? Where are the hexapoles? Where are the octopoles? We don't see them. The current geomagnetic pole shift is pretty minor, especially from a geologic perspective. Anyway, that's the last 4 hours of Earth's magnetic moment from the ground. It depicts magnetic flux density, the units of which are nanotesla. KP index only at 1.33 at the moment. 1.33 is the KP index. An average of global geomagnetism. And let's move on to the real-time solar wind. So we're showing the ACE here, and it's got a bunch of missing data. It stopped returning data here at around 5:45 Universal Time. So let's just switch to the Discover. Again, solar wind speed here pretty slow at 331 kilometers a second. Solar wind density here slightly elevated, just under 9 protons per cubic centimeter. The rest of that, not super exciting at all. GOES magnetometers here, seeing some higher readings, especially from the GOES 18. And don't expect any big perturbations in that until a coronal hole high-speed stream shows up. Then you can expect that to get a little bit choppy. Next, the top view ecliptic plane field plot. And again, we've got some significant magnetic variation happening around the eastern limb. Right now, Earth is in a North Pole current sheet. There you go. There's the polarity of the plasma. The polarity of the ecliptic plane. Indeed. Again, Earth is in a North Pole sector at the moment. There it is, shown in green. South Pole sector there, quite a ways off. Here's some more gong data. Our line of sight field plot. And you might see some motions happening over here around the east. That's what we've been talking about, this magnetic tug of war that's been going on. And it is still a bit indecisive as to which pole will win, as there is migration of magnetic fields happening over there. So it might look quiet from some wavelengths, but I assure you there is quite a lot of activity going on below the surface. Next, our ecliptic plane field plot, and you'll see this stuff waving around as well over there in the east, as the closest star endeavors to reach static equilibrium. Something that you certainly don't want it to do, because you want sunspot cycles to continue. So that's what's going on from the line of sight ecliptic plane field plot. One of our latest additions to the daily space weather. And here's our line of sight coronal hole plot. So we do have some, you can see some South Pole coronal holes popping up there. Again, there is magnetic indecision happening. Anyway, here's the latest image. So these latest coronal holes are of North Pole orientation. So it's all about North Pole. This one down here is North Pole as well. And this one, we can expect to have a significant solar wind uptick associated with that coronal hole system. And here's a great close-up of it, giving you the Earth scale there to get an idea of the size of those solar atmospheric features. So that brings us to sunspots. And again, we've got multiple new sunspot groups showing up in the northeast. They have not been named yet, which has caused the sunspot number to dip since yesterday. There you go. It's only at about 32 sunspots. So I admit it, I was incorrect. I expected the sunspot number to come up today. You can expect it to come up and exceed 50 into tomorrow, because again, if there are 4 new single sunspot umbrae, you can expect it to go up by 24. Each umbra counts as 6 sunspots, and I don't want to really get into the explanation of that. It is the daily space weather after all. Here is our flare probability monitor and scoreboard. So again, I counted 4 distinct sunspot groups. There's one there, one there, one there, and one there. So we'll show some high-res images of that toward the end of the video here. But before we do that, how about a cosmic ray update? We haven't done it for a while, and it's time to look at cosmic rays, which, by the way, are up over the past 30 days. You might find that surprising, or maybe not, considering the low levels of solar activity we've seen. Cosmic ray flux is inversely proportional to the sunspot number and the radio flux, if you weren't aware. At solar maximum, we see the lowest levels of cosmic ray flux, and at solar minimum, we see the highest levels of cosmic ray flux. So there's the Apatity neutron monitor, a significant uptick over the past 30 days at Apatity. And at Barentsburg, well, I have no idea, because it's not showing up. Oh, it's not showing up for the past day or so. So an uptick there at Barentsburg as well for the past 30 days. Next, we'll go to Athens, Greece, except, Athens, Greece not showing up at all, so let's move to Mexico City. And a similar graph there at Mexico City. A significant cosmic ray uptick there at the Mexico City Cosmic Ray Observatory. We'll also show Oulu, Finland. There is the Oulu neutron monitor. Very similar graph there indicating corroboration between the cosmic ray observatories. That's a good sign. It indicates the data is probably correct. So 30 days of upticking cosmic ray flux there at Oulu, Finland. DOMB Antarctica agrees, up over the past 30 days, and DOMC Antarctica agrees as well, up over the past 30 days. So a global uptick in cosmic ray flux for the past 30. Now let's briefly drop back here and look at sunspots. So there are sunspots from the SDO, the HMI instrument, as well as the AIA 131 angstroms. Let's drop the 131 angstroms. And you might not be able to see it. All these sunspots up here are kind of small, but there are certainly some sunspot groups up there. So as far as energetic particles, no spikes in the proton flux. It remains at baseline levels. We have seen some C-class flaring, the largest of which was about a C5, a little under a C5, a C4.24 class flare right at midnight on October 24th. So as day broke today, the largest flare of the past 24 was just subsiding. And here are some good wavelengths to highlight flare. Oh, wait, first the magnetometer. So what we're talking about here with this magnetic tug-of-war is, look, you can see all these areas of mixed magnetism. So this is South Pole polarity, here's North Pole, here's more South Pole, here's a big blotch of North Pole, more South Pole, more North Pole. And so anyway, still waters run deep when it comes to the closest star, and over there on the east side, they are certainly a little more turbulent than may be obvious from the ultraviolet spectrum. Here's 131 plus 94 angstroms. These are the wavelengths that are good at highlighting solar flares. And again, I would note most of the activity there in the northeast, a little bit in the southeast, and let's take a look at some star charts. Oh wait, first the northeast. Here we go. Here's a close-up of that northeastern limb. And again, we'll show you those 4 new sunspots before we get to our meteorology segment. That is what's going on. And like I said, a star chart comes next. There you go. That's what's going on overhead. Cygnus is high in the sky. And there is the current situation. The sun just approaching the horizon there over Lehigh Valley, Pennsylvania. You've also got Saturn and the moon up. And if you have a low horizon and clear skies and low light pollution, you might be able to see Mars there right after sunset. You're less likely to be able to see Mercury. If you are at the equator, you've got the best chance, especially if you've got a western view of the ocean. You might be able to pick up Mercury there, especially if you've got a telescope. Next, the solar system forecast. Here's where things are today. We'll advance this 1 week into November. That's where things will be on November 1st. And the astronomy photo of the day is actually a video. So let's briefly play that. We've got it at double speed here for you. And what you're seeing there, the reason the sun looks so choppy is because of the different atmospheric layers. Different atmospheric layers have different density and different chemical compositions. And so they cause light to be not only shifted in color, but also shifted a bit in direction. So that is why you see those refractions of light happening there. It's because of the different atmospheric layers being highlighted by that sunset And if you want to view that yourself, it's apod.nasa.gov. By the way, folks, apod.nasa.gov. And let's get to coronal mass ejections. It's been pretty quiet for the past 24. Some minor events there out of the northeast. You may be wondering if those are earthly directed, and the answer is probably not. So there are our SOHO coronagraphs. The SOHO spacecraft is located outside of Earth's magnetosphere at Lagrangian point 1, around where the ACE and Discover are located. And again, it has been pretty quiet. Just one significant CME, coronal mass ejection, over the past 24 hours. We'll also show Stereo A located out here, ahead of Earth orbitally speaking. It's about to be viewing space weather that the Earth is unable to see. In fact, it's already able to see a little bit behind the western limb because of its location. Stereo A coronagraphs here shown. Raw coronagraph on the left, difference imagery on the right. We have the left a little bit ahead of the right, so if you see something going on there, look over to the right side to see the difference imagery. Again, pretty quiet for CMEs over the past 24 hours. We'll also show coronagraphs anyway, our custom views. There's the SDO 193 plus SOHO coronagraphs. Here's a little closer zoom. And those coronal holes very well defined in the 193 angstroms as well as 211. And we'll zoom in one more step and add 304 angstroms. And there's the full disk view, great view of filaments there when the SDO is not calibrating at least. And there still is a crown prominence hanging out around the northern polar region. And let's get to filaments. It's about that time. Time to talk filaments. So there are filaments from Big Bear, California. And by the way, one of our viewers named this one. I named this one, and this one, and this one, and this one. If you want to know who they're named after, well, you've got to follow us on Twitter. Thanks to our new Twitter followers. Congratulations on realizing the Twitter channel exists. As we approach 500 followers. By the way, we've got over 22,000 tweets. And we've had a Twitter page since 2019. And we don't even have 500 followers despite daily original content and regular interaction. So I'm sure it's just a coincidence, folks. It makes total sense, right? Yeah, it makes total sense. Nothing to see here, folks. Here is, once again, the Big Bear Observatory. And we do have additional prominences here hanging out behind the northeastern limb. So, again, possibly new sunspots rising. And before we get the bonus features, let's take a look at the latest from the GOES 16 SUVI. Is it the 16? Yep, still the GOES 16 SUVI. There you go. That's the past about 2.5 hours. Could be a CME popping off there around the North Polar region. If so, it is very unlikely to be earthly directed. And let's get to our bonus feature segment here at the Smash News Network. Least busted name in news. And let us know in the comments what you think of the rebrand. You may have noticed we've got a new avatar on YouTube now, featuring a 171 angstroms image of the sun and the SNN logo. First bonus feature is satellite charging hazards. We don't have any. No low-energy electrons or high-energy electrons affecting satellites at the moment. GOES electron flux here coming way up off the floor in a moderate range there. So finally seeing a break in the electron flux drought. And there is the 1-year graph to contextualize it. We're still a little bit lower than average there, but coming up off the floor are the greater than 2 mega electron volt electron fluents. There's a forecast model, NOAA expecting a further uptick. I would tend to agree, and then a downtick when another coronal hole high-speed stream shows up. So that's what's coming next. The NOAA forecasts are the green boxes. The yellow diamonds are the observation. Next, we'll show the layer where it's measured. It uses radiography to measure the F flare's electron flux. The F flare is located at about 300 kilometers of altitude, and here is the vibrational frequency therein. So that's one slice of the atmosphere. The F ionosphere, it's at about 300 kilometers of altitude. We amass this data daily because you never know when it will become useful in the future. One of the many features of our channel is we've amassed massive quantities of data, which perhaps will become relevant to some unknown thing in the future. We show the ionogram and the anomalygram on the daily. So pretty normal looking ionosphere here at the moment. Nothing to write home about. And nothing to suggest that doomsday is upon us. Here's the latest image, 21:45 universal time for the raw vibrational frequency, and there's the anomaly in megahertz from a 30-day median. A great time to be highlighting the South Atlantic anomaly here over the South American continent. Next, the whole atmosphere model, the global ionosphere nowcast. As we transition from the ionosphere to the total electron content, which is shown on the left, maximum usable frequency there shown on the right, along with the anomalies for both, showing you what's going on at a glance in a little different type of visualization there. We'll also show total electron content over North America, and I'm skipping this entirely because I don't like the way it looks. I think it's erroneous. So let's move to the North American total electron content, as this looks like valid, legit data. So there is the anomaly from the 10-day average over North America, and that, my friends, is unremarkable. Last but not least, we'll go to the latest images. And again, you can see a bunch of activity up here in the northeast. Let's show those sunspots. So there you go. That is... So now it's looking like 3 sunspot groups, but... So this is going to be one group. This will be a group. And this will be a group. So at least 3 new sunspots up there are still likely to get named. No new ones down there. Here are the magnetic fields. They are pretty simple sunspots. So the likelihood of solar flares not really going up very much. This sunspot down here is still beta gamma class, if you're wondering. And is that a new group down there ahead of that one? Oh, another new sunspot formed right there. So there's another group. So it could be as many as 4 new sunspot groups tomorrow. So there you go. Could be 24 sunspots added to the sunspot number, assuming no other sunspots evaporate. And let's go wave chasing. It's time, folks. Time to do meteorology, and it's some interesting stuff going on with meteorology for sure. So let's do it. First, the biggest waves in the world are located in the subtropical Atlantic. So this system here has degraded a little bit since yesterday, but it's still producing about 32-foot waves. Those are the world's largest waves. The oceans are fairly calm right now. It's depicting surface winds and significant wave height. So pretty calm as far as big waves right now. Some on the coast of Argentina, though. So perhaps some good surfing down there in the Argentinian spring. Anyway, let's look at air masses as we're wont to do most days. There are the surface winds of the east, and like sands through the hourglass of time, these are the jet streams of your lives. Shout out to our viewers from the east side. Shout out to our viewers from the central world, Europe, Africa, and the Middle East. There are your jet streams. Here are the surface winds of the central world. Surface winds of the west. And let's don't forget the jet streams, which were quadrupled up yesterday over the eastern U.S. Now they're still tripled up over the western Atlantic. Big jet stream convergence happening there right around Lake Superior. And let's move on to show precipitation type. So there you go, a bunch of snow falling in the northwestern portion of the country there. North Dakota, Montana, Wyoming, Idaho, Oregon, Washington, California, Nevada. All seeing some snow there. And let's check snow depths. Here's the current state of snow in the U.S. Yowzers, look at all the snow up there. And that is over 10 feet. That's a glacier. So yeah, some heavy snows falling as we make the video. Heaviest portion here is currently, as far as the new stuff, 10 inches there in northwestern Montana. That's a snow depth from windy.com. Next, the visible satellite over the Americas. And we love doing these videos at sundown now instead of at sunrise because we can show the visible satellite, which is just spectacular. It's much better than the shortwave radiation if there is ample sunlight for it to show you anything besides pure darkness. And check out this tropical system here in the subtropical Atlantic. I'm going to show that breaking down a little bit. There you go. It had a pretty well-defined eye wall there, and it has just, throughout the day today, broken down. I believe there is a lot of wind shear involved with that one. And as the sun sets, you can get a great view of those variations in the cloud heights. Sunset, a great time to look at the visible satellite imagery. So that's what's going on there. Here's our weather.gov map, and dag, look at those winter storm warnings. Pretty berserk. Weather.gov, also some flood warnings there. Some major rains coming to Texas, Oklahoma, and indeed Kansas. So there's the key. If your county or waterway is lit, head to weather.gov and get your personal locations weather warnings. Those are too many counties and waterways to cover, so here come some forecasts from Tropical Tidbits. TropicalTidbits.com. We show the forecasts daily. Shout out to Dr. Levi Cohen, I think. Anyway, here comes some forecasts. The GFS 72-hour pressure and precipitation forecast. That snow is going to linger around for about 2 days and then take the express route to northeastern Canada. That's probably going to show up at Greenland and drop additional snow out there at Greenland. So that's pressure and precipitation. We'll also show total accumulated snow depth change. And you can see there an additional foot plus to fall in portions of Wyoming and Montana especially. 72-hour GFS positive snow depth change forecast in inches. Dag! Next, total accumulated precipitation forecast, GFS 72-hour model. And especially Oklahoma there, expecting an additional 4 inches of rain. Also in parts of Kansas. So that's the source of the flood watches. Also temperature anomaly forecast in degrees Celsius on the GFS model. And we had near record high temperatures in Pennsylvania and more to come. Expecting temperatures like 12 plus degrees Celsius above normal for large swaths of the eastern U.S. And frigidly cold temperatures there in Montana. Over 16 degrees Celsius below normal, coming for days. So a lot of that snow will stick around. Those are the facts. Next, showing lightning for the past 54 images there. That's about 11 hours. You can see some lightning there across Texas, some in New Mexico, Kansas, and Oklahoma especially. We do have some current strikes here. There is where the current cells are located, west of Dallas-Fort Worth. Some thunder rolling in at Fort Worth at the moment while we created the video. Lightningmaps.org. Next time you hear thunder, highly recommend it. And from a global perspective, pretty low as far as lightning here at the moment. Only 66 strikes per minute. Some in the north central Mediterranean, it looks like there. And we're going to close this thing out with U.S. Doppler radar. Especially for the lower 48. There's the visible satellite. And there is the water vapor map. When your Doppler's unclear, check out the water vapor map. It'll clear things up. We do have an anticyclonic system here. Check it out. Right here, this is an area of high pressure. And we are indeed seeing a clockwise rotation there, a really huge clockwise rotation, an indication of an upper level high. It is a pressure being exerted on the atmosphere. Here's the recap. U.S. Doppler radar depicting vertical motion in the air column. Visible satellite. And once again, the water vapor map. Hopefully the space weather content you've been viewing up until now isn't water vapor crap. And we'll see you soon from the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.